NEC Article 100 defines a battery charger as an appliance or a combination of appliances for converting alternating current or direct current to direct current for charging batteries. Therefore, battery chargers are considered appliances under the NEC. NEC Section 422.31 requires that appliances generally be connected by permanent wiring or by listed cord and plug connections. In this case, a cord and receptacle assembly meets the NEC definition of a listed cord and plug connection. Therefore, it is an acceptable means of disconnecting the battery charger. NEC Section 400.8 requires that the appliances be installed in a manner that prevents their movement from affecting their electrical connection. This can be achieved by either permanently wiring the appliance or by using a listed wiring method that prevents movement, such as flexible conduit. NEC Section 240.4 E requires that overcurrent protection devices be located at the point where the branch circuit enters the appliance. In this case, fuses located inside the battery charger cabinet provide overcurrent protection. A cord, cap, and receptacle assembly is Underwriters Laboratories listed. This means that the assembly meets the applicable Underwriters Laboratories standards for safety and performance. Based on the information provided, the battery chargers are installed in accordance with the NEC as follows. Firstly, they are using a listed cord and plug connection as a means of disconnect. Secondly, they are protected by overcurrent devices. Thirdly, the cord, cap, and receptacle assembly is Underwriters Laboratories listed. Therefore, a requirement for fixed wiring is not necessary, and the use of the cord and receptacle assembly is acceptable. Looking at the specific installation described, there are 12 forklift battery chargers, 5 single-phase and 7 three-phase, operating at 480 volts. The loads vary from 6 amps to 19 amps. These chargers utilize cores and attachment plugs, specifically twist-lock plugs rated for 480 volts at 30 amps. A fuse block inside the charger cabinet provides overcurrent protection, with fuses rated at approximately 180% of the load. For example, a 7 amp rated unit has 12 amp fuses. The installation uses 30 amp circuits for both single and three-phase chargers, feeding 30 amp 480 volt receptacles. In many cases, two chargers share a single circuit, with a combined maintained load not exceeding 23 amps. The circuit breakers are within sight. The key questions revolve around how the NEC views a battery charger, whether it is considered an appliance or utilization equipment, whether it must be fixed in place with hard wiring to disconnect, and whether an attachment plug receptacle assembly can serve as a means of disconnect. From a maintenance perspective, using cord and plug connections allows for easier disconnection when the units need to be shipped off-site for service. Now let's delve into the relevant NEC sections to address these concerns. As previously stated, NEC Article 100 defines a battery charger as an appliance. This classification is crucial because it dictates the applicable requirements for installation and disconnection. NEC Section 422.31 provides guidance on disconnecting means for appliances. It states that appliances must be disconnected from all ungrounded conductors by one of the following means. Firstly, a permanently installed disconnect switch or circuit breaker that is readily accessible to the user of the appliance. Secondly, an attachment plug and receptacle. This section explicitly allows for cord and plug connections as an acceptable means of disconnecting appliances provided the plug is readily accessible. The fact that the chargers use twist-lock plugs does not negate their acceptability as a disconnecting means, as long as they can be easily accessed by maintenance personnel. Now, let's address the concern regarding fixed wiring. NEC Section 400.8 outlines the permissible uses of flexible cords and cables. It emphasizes that flexible cords should not be used as a substitute for the fixed wiring of a building. However, exception number 3 allows for the use of flexible cord for connection of portable equipment. Battery chargers, particularly those that may need to be moved for service or relocation, can be considered portable equipment in this context. The key is to ensure that the cord is not subjected to excessive strain or physical damage, and that it is properly sized for the load it carries. The inspector's concern about movement affecting the electrical connection is valid. However, this can be addressed by ensuring that the cord is of sufficient length to allow for movement without putting stress on the connection points. Additionally, using strain relief devices at the cord entry points can help prevent damage to the cord and terminals. Another critical aspect is overcurrent protection. NEC Section 240.4 provides general requirements for overcurrent protection. In this case, the fuses located inside the battery charger cabinet serve as the primary overcurrent protection for the appliance itself. These fuses must be sized appropriately to protect the charger's internal components and wiring. The practice of using fuses rated at approximately 180% of the load is generally acceptable, provided it aligns with the manufacturer's recommendations and the specific characteristics of the charger. However, it is essential to verify that the sizing complies with NEC requirements for the protection of the branch circuit conductors. The branch circuit feeding the chargers must also have overcurrent protection, typically in the form of a circuit breaker. Given that the installation uses 30 amp circuits for chargers with varying loads, it is crucial to ensure that the circuit breaker is sized appropriately for the smallest charger connected to the circuit. NEC Section 210.20 specifies that branch circuit overcurrent protection must be sized to protect the branch circuit conductors and any equipment connected to the circuit. In cases where multiple chargers share a single circuit, the circuit breaker must be sized to protect the conductors from overload and to prevent nuisance tripping. In this scenario, where the maintained load of any two chargers does not exceed 23 amps, a 30 amp circuit breaker should provide adequate protection. However, it is essential to verify that the conductors are also rated for at least 30 amps, in accordance with NEC Table 310.15, B16. This table provides ampacity ratings for conductors based on their size and insulation type. It is crucial to select conductors with an ampacity sufficient to carry the load without overheating. The underwriter's laboratory's listing of the cord, cap, and receptacle assembly is a significant factor in ensuring the safety and compliance of the installation. Underwriter's laboratory's listed equipment has been tested and evaluated to meet specific safety standards. This provides assurance that the assembly is suitable for its intended use and that it meets minimum safety requirement. The fact that the manufacturer's owner's manual lists the cord, cap, and receptacle as optional equipment further supports the acceptability of using this wiring method. While the manufacturer's lack of responsiveness is frustrating, the information in the owner's manual can be used as evidence that the cord and plug connection is an approved method of connecting the charger. The inspector's request for manufacturer documentation is understandable, but it should not be the sole determining factor in the acceptability of the installation. The NEC allows for the use of listed equipment and wiring methods, even if the manufacturer does not provide specific documentation. In summary, the battery chargers can be connected using cord and plug connections, provided that the following conditions are met. Firstly, the cord and plug assembly is underwriter's laboratories listed. Secondly, the plug is readily accessible. Thirdly, the cord is properly sized and protected from damage. Fourthly, the branch circuit has adequate overcurrent protection. Fifthly, the installation complies with all other applicable NEC requirements. Given these considerations, the inspector's requirement for fixed wiring is not necessarily warranted. The use of cord and plug connections can be a safe and code-compliant method of connecting battery chargers, particularly in situations where portability and ease of disconnection are important factors. It is recommended to thoroughly document the installation, including the underwriter's laboratory's listing of the cord and plug assembly, the sizing of the fuses and circuit breakers, and the ampacity of the conductors. This documentation can be provided to the inspector to demonstrate compliance with the NEC and to address any concerns they may have. It is also advisable to consult with a qualified electrical engineer or inspector to ensure that the installation meets all applicable codes and standards. They can provide expert guidance and help resolve any discrepancies or questions that may arise. In addition to the specific requirements discussed above, There are several other general electrical safety practices that should be followed when installing and maintaining battery chargers. Firstly, always disconnect power to the charger before performing any maintenance or repairs. Secondly, never work on electrical equipment while standing on a wet surface or wearing wet clothing. Thirdly, use properly insulated tools when working with electrical equipment. Fourthly, regularly inspect cords and plugs for damage and replace them if necessary. Fifthly, keep the area around the chargers clean and free of clutter. Sixthly, provide adequate ventilation to prevent the buildup of flammable gases. Seventhly, follow all manufacturers' instructions for the installation and operation of the chargers. By following these safety practices can minimize the risk of electrical shock, fire, and other hazards. Furthermore, consider the specific environment in which the battery chargers are located. If the chargers are installed in a damp or corrosive environment, it may be necessary to use special enclosures or wiring methods to protect the equipment from damage. Similarly, if the chargers are located in a hazardous location, such as an area where flammable gases or vapors may be present, it will be necessary to comply with the requirements of NEC Article 500 and related articles. These articles provide detailed guidance on the installation of electrical equipment in hazardous locations. Additionally, the Americans with Disabilities Act may have implications for the accessibility of the disconnecting means for the battery chargers. If the chargers are located in a public area, it is important to ensure that the disconnecting means are readily accessible to individuals with disabilities. This may require the use of specific types of plugs or receptacles, or the installation of additional disconnecting means at accessible locations. Finally, remember that the NEC is a minimum standard. It is always permissible to exceed the requirements of the NEC in order to provide a higher level of safety or reliability. For example, one might choose to use larger conductors or more robust overcurrent protection devices than what is required by the NEC. These additional measures can help to improve the performance and longevity of the electrical system. By carefully considering all of these factors can ensure that the battery chargers are installed in a safe, code-compliant, and reliable manner. The use of cord and plug connections can be a viable option, provided that all applicable requirements are met and that the installation is properly documented and maintained. In conclusion, the inspector's concern regarding fixed wiring for the battery chargers is not necessarily justified. The NEC allows for the use of cord and plug connections for appliances, including battery chargers, provided that certain conditions are met. The key is to ensure that the cord and plug assembly is Underwriters Laboratories listed, that the plug is readily accessible, that the cord is properly sized and protected, and that the branch circuit has adequate overcurrent protection. By carefully following these guidelines, it is possible to install battery chargers in a safe and code-compliant manner, while also providing the flexibility and ease of disconnection that maintenance personnel require. If the provided chargers are multi-tap and are currently set up for 480 volts, they need to be tested as 480 volts. And whether there are 5 of the chargers that are single-phase and 7 that are 3-phase, they must be tested. The loads vary from 6 amps to 19 amps, but this is a testable value, just as the attachment plugs being twist lock 480 volts, 30 amp rated are testable. Be sure that the cords are in good condition and that the line cord attached to the fuse block is the first point of attachment inside the battery charger cabinet. Make sure that the fuses are rated for approximately 180% of the load, e.g. a 7 amp rated unit with 12 amp fuses. The inspector's suggestion for the charger to be fixed in place with fixing wiring or something from the manufacturer that states this as a UL rated installation may be a possible outcome based on the other test results. That 30 amp circuits are being used, single and 3-phase feeding 30 amp, 480 volt, 1/3ph. Receptacles should be tested. Be mindful that most of the chargers share a circuit with one other charger, and the maintained load of any two chargers is a maximum of 23 amps, like a 11 amp and a 13 amp. Be mindful that the circuit breakers are within sight. Lastly, if the manufacturer does not return phone calls but their owner's manual lists a cord, cap and receptacle as option equipment, use the owner's manual. In summary, there are many things to test and verify on site.